prove that the area of a regular hexagon with side of length s is this one. So we have a regular hexagon, meaning all sides are equal and all interior angles are also equal. So we have the side here S, 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 and S. So if we're going to divide that hexagon by joining the or drawing a diagonal, so this will gives us a equilateral triangle. We have 60, 60, and 60. So if we're going to redraw this triangle here, so we have S. So this must be S because this is an equilateral triangle, and also S here. So to find the area of this triangle, so we have to find the height first. So the height is equal to h squared plus, so this side here must be S over 2. This one here, S over 2 squared is equal to the hypotenuse S squared. So solve for h minus S squared over 4. So your h squared is equal to 3 S squared over 4. Square root both sides. This will give us the height of over 2. So to solve the area for this regular hexagon, we have 6 equilateral triangle here. So 1, 2, 3, 4, 5, 6. So the area of that hexagon is just equal to 1/2 base times height times the number of that equilateral triangle, 6. So the area equal to 1/2. The base is S and the height is S square root of 3 over 2, all multiplied by 6. So the area is equal to 3 S squared square root of 3 over 2. So we have proved that the area of a regular hexagon is equal to 3 S squared square root of 3 over